On a winter day in 1961, Edward Lorenz, a meteorology professor at MIT, entered some numbers on his computer to simulate weather conditions and went to get a cup of coffee. The numbers represented variables like temperature, wind speed, pressure, etc. as initial conditions. On that day, he was repeating a simulation he had run earlier. When he returned, he saw something peculiar. The weather conditions predicted for 2 months later were completely unrecognizable from his previous simulations. The graphs diverged so drastically, in fact, that he thought his computer had gone faulty and ordered repairs. But on investigating further, he realized the problem. He had rounded off one variable from 0.506127 to just 0.506. It was then that he realized that the approximate present doesn't predict the approximate future, and a butterfly flapping its wings in Brazil can cause a tornado in Texas. This is the butterfly effect. The butterfly effect is a consequence of a much more elaborate theory of chaos. The chaos theory's basic premise is that complex systems with many parameters like weather, stock market, and population models are highly sensitive to initial conditions. Even a change of a billionth of a percent in any variable can change the system's future state so drastically that it would seem unrecognizable. So although, theoretically, if we know the system's current state with 100% accuracy, we can predict the state of the system anytime in the future correctly. But exactly knowing the initial conditions of a system is a highly daunting task. For instance, take weather. Every cubic meter of air contains 10 trillion molecules. Measuring the velocity and position of each and every particle with 100% accuracy would require virtually infinite computing power. In fact, Heisenberg's uncertainty principle, one of the fundamental laws of physics itself, state it impossible to know both the speed and position of a subatomic particle with complete accuracy. Just take the example of a double pendulum. All you would need is the exact coordinates of pendulum blobs initially to predict the future state. But even a slight deviation, or incorrectly taking air resistance or friction into account, can cause a seemingly random behavior, which, although is deterministic had we known the exact state, but we perceive it as chaos, something which doesn't follow any rules, doesn't repeat cycles ever again, and is unpredictable. Chaos can be found almost everywhere. Take a dripping faucet. Have you ever wondered about the patterns of droplet falling? Well, it's chaotic. The initial conditions generated by one droplet, specifically the amount of water and duration of fall, influences the next droplet. Steadily, as time progresses, our initial measurements of the first drop prove inaccurate, as infinite accuracy is obviously physically impossible, and as these errors pile up, we again end up observing a seemingly random, chaotic pattern of droplet falling. But apart from the household chaos, it is the stock market and finance sectors that are seeing a wave of disruption from a new way of explaining things. What is better to describe the haphazard rise and fall of stocks, unemployment rates, and interest rates than chaos itself? Although AI and machine learning algorithms already use predictive analysis, chaos mathematics is an awesome tool in their arsenal. Previously, they could only spot obvious long-term trends, but chaos allows them to take into account all the interdependencies, positive and negative feedback loops, psychologies of investors to foresee the markets at a much smaller scale. Obviously, measuring all the factors and more is a humongous task. Like the weather, it is next to impossible. Still, chaos allows scientists to realize their own limitations instead of seeing their systems as unpredictable and random. In the end, this is what often leads to revolutionary breakthroughs and quantum leaps. It is often thought that events that change the world are the big ones: atom bombs, meteor strikes, or birth of certain people. But this is often considered naive and held by people completely out of touch with modern thought. It is the small things that have the most impact. The world, after all, is a complex system and has sensitive dependence on initial conditions. A butterfly flapping its wings might cause a tornado or may prevent a hurricane. But the importance of these small phenomena is often understated in terms of impact. Alexander Fleming was a professor of bacteriology in London in 1928. While working at a lab in St. Mary's Hospital, he decided to take a week off, but forgot to clean up his messy lab. When he returned from the vacation and started cleaning his lab, he found that petri dishes with staphylococci were contaminated with a mold, which prevented bacterial growth. The mold was penicillin. The first naturally occurring antibiotic drug was discovered. It cured fatal diseases like rheumatic fever, gonorrhea, tuberculosis, and pneumonia, and ushered a new age of medicine. Just imagine the number of lives that drug saved. It changed entire bloodlines and family histories. Your favorite companies, leaders, corporations might have been radically different had Alexander remembered to clean up his lab. He later wrote, "When I woke up just after dawn on September 28, 1928 to clean up my lab, I certainly didn't plan to revolutionize all medicine by discovering the world's first antibiotic, but I guess that was exactly what I did." During the US-USSR conflict in 1962, things took an interesting turn. A Soviet B-59 submarine was under harassment from the American naval forces near Cuba. To avoid detection, the B-59 dove way down the ocean and could not communicate with Moscow for several days. The US forces started dropping practice depth charges to signal the submarine to resurface, but the captain took these to be real depth charges. With no communication with Moscow, he thought the war had already started. He immediately ordered a 10-kiloton nuclear torpedo to be launched on enemy forces. But Vasily Arkhipov, a crew member, refused and convinced the commander to reconsider a potentially irreversible action. The captain calmed down, resurfaced, and contacted Moscow for new orders. Had Vasily Arkhipov agreed, a full-blown nuclear war, leading to a nuclear winter and eventual endangerment of human species, was inevitable. Obviously, what all of this refers to is not that every action of yours would end up changing the world order. Still, you never know which action of yours might start the domino effect of causations, changing your life altogether. Learn a new skill, put it to good use, help people, interact with the world positively, and when you get old, you would be surprised how sensitive your life has been to initial conditions. And as always, thanks for watching.